Now right angle triangle. So we already know Pythagoras theorem for right angle triangle. So I think we don't need to spend more time on this. Many people must be aware of this. We have solved or used this theorem hundreds of times in school. So Pythagoras theorem is AB square plus BC square is equal to hypotenuse square. That is AC square, right? Now median of hypotenuse is half of median to hypotenuse is half of hypotenuse. So if you draw this BD is half of AC, and in short that means BD is equal to AD and CD as well. Now this is one special case in case of right angle triangle. One more important property is that D is a circumcenter. So where is the circumcenter of a right angle triangle? So circumcenter of a right angle triangle is on the hypotenuse, and that's nothing but the midpoint of the hypotenuse. And if you draw a circle, you'll see a circle like this. So please note down this as well. This is something important. If you know it, it will save your time. You might come across some simple question based on this property. So this is one very important property. Next. So this is valid for any right angle triangle, that circumcenter is always on the hypotenuse, and that's nothing but the midpoint of the hypotenuse. And median to the hypotenuse is always half of the hypotenuse. So I have seen some simple question, and it's just a matter of recalling the property. Those who can recall the property, it's a simple question for them. I'll show you it's in some actual question as well. Now in case of right angle triangle, if you draw the altitude to the hypotenuse, let's have a altitude B on hypotenuse AC. So we have one very important property. Please make a note of this. B square is equal to AE into EC. So I hope you can easily remember this. This is your B square, and that is equal to multiplication of AE and C, or AE and EC. This is actually derived from similarity. We are yet to discuss that. We'll discuss that later on. But for the time being, this is a direct property. You can note down. So B square is equal to A into C. So E is a common point to all. You can clearly see E is a common point to all the segments. Let's see 30, 60, 90 theorem. If this is a triangle, and if this angle is C is 30 and angle A is 60, in that case side opposite 30 is half of hypotenuse. I hope you still remember that. Side opposite 30, that is half of hypotenuse. So AB, which is a side opposite 30, you can clearly see this is the side opposite angle 30 degrees, and that side AB is half of hypotenuse. And in the same way, we have one more property. Side opposite 60 degrees is root 3 by 2 times hypotenuse. So this is your side opposite 60 degrees, right? So that is root 3 by 2 times hypotenuse. So once these are also some important properties which you will come across frequently in different questions. You don't need to know the entire trigonometry, but these few basics of trigonometry are important. Yeah, if you have to write the ratio, you can write the ratio in this format. The ratio of all the three sides is 1 is to root 3 is to 2. But they are derived from the original two statements which are written on the top. The 30, 60, 90 theorem. In the same way, we have 45, 45, 90 theorem. So if you have a triangle like this, then side opposite 45 degrees is 1 by root 2 times hypotenuse. So you can take any side which is opposite 45 degrees. So either you can go for BC or you can take AB as well. So any of these two sides will be 1 by root 2 times hypotenuse. That is 1 by root 2 times AC. Fine. And in the same way, if you have to write the ratio of the sides will always be like this. 1 is to 1 is to root 2. Let's move ahead. Let's have equilateral triangle. If you have an equilateral triangle like this, equilateral triangle means all the sides are equal, all the angles are 60 degrees. And in this, if you draw an altitude, So just to update you what I was talking about in one of the earlier slides, that your altitude is also the median, it is also the perpendicular bisector, it is also the angle bisector. Can you all see that? Hope you all can see this. So for me, AD is also the altitude. You can see a 90-degree angle here. It is also bisecting the sides. It is also the angle bisector. You can see 30 degrees angle written over here. So this is what we have in equilateral triangle. Therefore, circumcenter, centroid, incenter, orthocenter, all the points are same. So basically we prefer to write G for centroid here. So let's see the further other additional properties in equilateral triangle. But this is one important thing. You can note down the diagram. You can draw the diagram. Let's move ahead. So how the area is derived, how the area of the equilateral triangle is derived. If you know the original formula for the area of triangle, so original area for the area of triangle is half into base into height. Now here you can take this side as A everywhere, or you can take it as X if you want. So when it comes to the height, this is your height. Height is nothing but the side opposite 60 degrees. Can you all see this? If you take a triangle ABD, so your AD is nothing but a side opposite 60 degrees, and by using that, this particular expression is derived that height is equal to root 3 by 2 times this side. And let's see the discussion further. So circumradius, so AP, that is the upper part. Upper part will be 2/3 of the height. In radius will be the lower part, that's the lower part, that will be 1/3 of the height. Now area of the triangle, this is what actually I was talking about. So if I were to write the area of the triangle, so if we substitute half into base will be nothing but A, right? And height we have already written it over here in the first statement, root 3 by 2 times side. You can write it as root 3 by 2 times A. So if you write root 3 by 2 times A, and if you solve this further, ultimately you will have root 3 by 4. This 2 and 2 gets multiplied, and this, if you multiply this A and A, that will give you A square. So root 3 by 4 times side square, or root 3 by 4 times A square. That's the formula for equilateral triangle. In fact, we have discussed this formula in the topic of mensuration as well. But for the time being, this is your explanation for equilateral triangle. So please note down all the different properties that we have in equilateral triangle. Especially circumradius is nothing but 2/3 of the height. Circumradius, I hope you all know, if you take this as the upper part as the radius, and if you draw a circle, it will pass from all the points like this. This will be your circumcircle. And if you take the lower portion as the radius, and if you draw it, you will have a in circle like this. Like it's not a free flowing movement on this white board, but I hope you can visualize the diagram and you can understand what exactly I want to convey from in circle and circumcircle. Okay, I hope you have noted the derivation of the area. It is also discussed in the topic of mensuration, so I'll just clear this space. Let's discuss few more things in geometry, especially related to triangle. So let's have area of triangle. You already know one form of the formula. So apart from that, there are some more formulas available for getting the area of triangle. So we'll start with the basic formula that we already know. Area is nothing but half into base into height. That's the basic formula for the area of triangle. Now apart from that, I was talking about there are few more formats available. This is called as Heron's formula, where area is equal to square root of s into s minus a into s minus b into s minus c. We had discussed this in the topic of mensuration as well. So anyway, let's note it down again if you haven't noted it at that time. What is S? S is nothing but the semi-perimeter, so it's the half of the perimeter. So perimeter is going to be A plus B plus C, and divided by 2, that will be semi-perimeter. So this is a Heron's formula. So even this was there in school syllabus, The next few formats you might not be aware about. So just make a note of it carefully, and most of the time whenever the questions has come, I have seen a direct question. So it's just a matter of knowing the formula. So this is one more format. It might be helpful in certain questions. So area is equal to half into A into B sine theta. I'll just clear what exactly is this. So if I draw one height here, so height is, this is the side in front of the theta, and if you consider, if I write D here, so in triangle CDB, you can see BD is the height and this is going to be the hypotenuse, right? So we can, if you know the definition of sine theta is nothing but opposite side upon the hypotenuse. So sine theta can be written as, so for theta the opposite side is h, upon the hypotenuse is a in this case. So you get height is equal to a sine theta. So it's actually the simplification by using a bit of trigonometry. So originally the formula should have been half into base is still b into a sine theta, that's your height, right? So there are two more formats available, we'll discuss that, but this is a derivation of the logic behind this. Fine, let's come to the next one then. So if this is your triangle, then A is equal to RS, where R is end radius and S is semi-perimeter. So in case if the question has already given you end radius, or if by any mean you can get end radius easily, then this is the best way to get the area. So most of the time whenever such question has come, first of all the chances of getting such question is very rare, but if at all it comes, 90% chances are there that the information is directly given to you in the question. And S is semi-perimeter, I already told you about that. One more formula, where in the earlier formula, I'll just show it once again. In the earlier formula, R was the end radius, and end radius comes from in circle. We use small r for this. In the next formula, we are using big R or the capital R. So in this case, R is going to be the circumradius, and just the way I told you in the earlier example, in case if you have to at all use this formula, in that case also 90% chances are there that all the information is directly given to you. You have to just simply substitute the things in the formula and you have to get your answer. So this is the last formula for the area of triangle. You can make a note of this. And as I told you, very rarely I have seen questions based on this property, but it's a matter of just knowing the formula. If you know it, it's a matter of few seconds for you. So let's move ahead.